Question 9, we've got a ball being thrown and the ball tracks a path as per this line here. Ball is thrown from point A, arrives at point B, and with respect to the fixed origin 0, the coordinates of the starting point and the ending point is 0, 2 and 20, 0.8 as shown in the figure here. The ball reaches a maximum height where x is equal to 9. A quadratic function links h with x and is used to model the path of the ball. Find h in terms of x. So yeah, the question is telling us that this is part of a quadratic curve. So the quadratic curve for this type of situation is best described in its completed square form. So that h is equal to a x minus b squared plus c. So from the model and from the description of what the ball does, we've got to find the constants a, b and c and apply that to the flight of the ball. And the one thing we are told is that the maximum height of the ball is given when x is equal to 9. So when is the maximum height achieved here? Well, the maximum height will be achieved when this term goes to 0. Because given that this is an n-shaped quadratic, this term here, the a term, will be negative. So I've said here, as h is a maximum when x is equal to 9, I know therefore that b must be equal to 9. So how do we work out a and c? Well, a and c we can work out using the 2 points we're given. So if we sub that h is equal to 2 when x is equal to 0, let's see what we get. So plugging these two values in to start with, we get that 2 is equal to a, b is 9, x is 0, so this is negative 9 squared plus c. Simplifying that up a little bit, I get that 2 is equal to 81a plus c. Now substitute our other two values. So 0.8 is equal to a. This is now 20 minus 9, so that's 11 squared plus c. Again, simplifying a little bit, we've got 0.8 is equal to 121 a plus c. Simultaneous equations, this is equation 1, this is equation 2. So if you solve these two simultaneous equations, equating the c's, for example, or eliminating them, you get that a is equal to negative 3 over 100, and c is equal to 443 over 100. So putting those both into h, we get that h is equal to negative 3 over 100, x minus 9 squared, plus 443 over 100. And that's the answer to part A. A limitation of the model? Well, a limitation would be no account has been taken here of air resistance, because we've got this perfect parabola where the horizontal velocity remains unchanged. But as we know in the real world, the horizontal velocity would be reduced by the fact that the air is pushing backwards. So let's just say air resistance is ignored. And that's part B out of the way. Part C. So we've got Chandra, who is standing under the path of the ball at a point 60 meters away from O. So he's roughly here, and he's able to catch the ball if the ball is less than 2.5 meters above the ground. So what we've got to do is we've got to find h at this point, where x is equal to 16, and see whether that is greater or less than 2.5 meters. So we need to sub into our equation x is equal to 16. Fairly simple substitution, and if you put 16 into here, this becomes 7, and if you put that into a calculator, you get the fact that h is equal to 2.96 meters. So the conclusion is that as 2.96 is greater than 2.5, Chandra cannot catch the ball because it will be out of his reach. And that's the end of question 9.